Hello to everyone. Welcome to the information session of this edition of the International Masters in Theoretical and Practical Application of the Finite Element Method and CEA Simulation. Michael Disi and myself, Ronald Siat, are going to talk you through the session, which will take approximately 45 minutes. At the end of the session, we will give you an email address and phone contact to ask any questions you might have, and the Master Secretariat will promptly answer them for you. As well, you can use this application and place your questions using the tools that the GoToWebinar has for you. As well, this webinar will be recorded and it will be available on your registration emails and the master's website. We will outline the objectives and structure of the master's program as concisely as clearly as we can. Let's get started.
I will cover each of the areas shown on your screen. I will outline general context, go over the features of the program, the different degrees, branches and options available, as well as the course structure, the modules which can be taken, and the methodology applied. I will also give you some background information on the program and the team behind it. Towards the end, I will draw your attention to the master's calendar, registration dates, and secretariat contact details. This slide gives a summary of the objectives of the masters, but we recommend that you go to the master's website, which is shown on your screen, and there you will find comprehensive information on the composition and functioning of the masters. Attendees on the master's program are mainly from two areas. One, professional engineers working in the industry who want to enhance their CAE skills. And two, new engineering graduates and graduates from other science branches. The masters not only provide you with an in-depth understanding of the finite element method and the necessary tools to use it, it also trains you how to apply the knowledge directly in engineering companies, in areas of scientific research, and other advanced studies related to this field. For UNED and INCE Cyber, it marks an important milestone on the journey together and their unwavering commitment to excellence in teaching, research, and innovation in the different engineering fields. The program is not the work of any one person or organization, but the combined efforts of many engineering companies, university engineering faculties, and multiple professionals. It is why the International Masters is widely acclaimed by experts in the industry worldwide. In the early 90s, the need for specialists in the use of FIM and CAE simulation for practical professional applications was clearly identified. It was then that INCE Cyber approached UNED with the idea of formulating a master's degree program. A select team of highly experienced engineers and senior professors came together and designed a pilot study program. It was enthusiastically welcomed by the industry, and within a few short years, it evolved into the International Masters in Theoretical and Practical Application of FEA and CAE simulation. Through the program, UNED and INCE Cyber have engaged with industries, governments and universities all across the world. The partnership has developed important relationships with a select team of global technology and business partners. About UNED. UNED of Spain is one of the most renowned and experienced distance learning universities, specializing in technical degrees. Through the ubiquitous connectivity of the internet, UNED has become a distance learning powerhouse. and uses social media, virtual classrooms, and video on demand as ways of enhancing the learning experience. It has 2 engineering faculties, multiple postgraduate and PhD programs, and a teaching staff of over 7,000. For students, UNED has a uniquely dynamic structure and incorporates the latest innovations and technology into its courses. About NK Cyber. Founded in 1986, NK Cyber is an engineering company and provides finite element analysis consulting to the industry, CAE technology to improve design processes for mechanical, civil and fluid system calculation and training. NK Cyber plays a major role in the FIM Masters program. NK Cyber coordinates the Masters and staffs the Secretariat, has responsibility for global marketing, commercialization and management of the program, as well as the development of educational and training materials and the application and practice subjects for the Masters. Tutoring in the expert module and different specialized modules is done by qualified NK Cyber personnel. The company also develops and provides CiberFIM software. From here, we take a closer look at the Master's program. One of the most significant features of the program is that it is 100% online, with easy access to professors and lecturers. The learning methodology is backed up with materials specially prepared to facilitate the recommended learning process. Another significant feature of the Masters is the appropriate balance between the theoretical contents and their application using the software. Both parts are deemed essential to train professionals in the industry.
The expert in theoretical and practical application is the base. Will include the basic modules. There are 5. Later you will see. Then you will have the specialist, which is the expert degree plus 1 specialized module, and then the masters in one branch or another, which is the expert module plus specialized modules and the final master's project. These 3 includes fundamentals and the practical application using a software. Here you have the full course structure, include fundamentals and practice with the software.
The expert module consists of 4 foundation subjects: FEM General Theory, FEM Introduction to Programming, Numerical Calculation and Material Constitutive Laws, and 3 application and practice subjects. The foundation subjects give you a fundamental understanding of the finite element method, which is essential in order to understand what you are going to do with the application software. These foundation subjects are common to both engineering branches. The application and practice subjects are studied at the same time as the foundation subjects. These practical lessons will equip you with the skills to perform a complete finite element method analysis, including the stages of pre-processing, solving, and post-processing. For all modules, UNED and NK Cyber will provide the materials for the different subjects, the educational software, and any additional study material needed, such as exercises to complete the program. As the Masters is delivered online, the virtual classrooms are used to centralize the tools available to you. It is there you access study materials, continuous assessment exercises, and self-assessment exercises. There will be online meetings, and you can find more information about them in the virtual classrooms. You can also post questions in the online forums of each subject, and they are answered by the tutors. Exams are also conducted there. The primary objective of the Masters is to provide professional training in FEM. During the program, you will have the opportunity to solve industry-specific simulations such as structural analysis, steel structure advanced analysis, nonlinear concrete analysis, dynamic analysis, nonlinear, thermal and composite structure, pressure vessels, heat exchangers, pipelines, automotive parts, etc. The examples I have just mentioned focused exclusively on professional applications. This is a very important concept present in the whole master's program. Not only is it about solving basic teaching cases, but also about developing the cases to real applications to also learn, for example, modeling criteria applicable to real models. Specific real cases solved during the master's program are presented in the explanation of each module in slides coming up. Is a general purpose FIM software, and FIM techniques are valid for many different types of industries: aerospace, automotive, oil and gas, nuclear power plants, to name but a few. Here you can see structures of different industries analyzed: a steam condenser, a bolted flange, an offshore platform, a storage tank, and a high voltage tower. These examples are solved in the expert module of the mechanical branch. In all cases, checking of the structures under operation loads is very important to validate the design. For example, internal pressure in the storage tank. Combinations which are usually calculated due to norms are also obtained. If you advance to the specialist degree, you have specialized modules to choose from. The specialized modules are dynamic analysis, non-linear analysis, heat transfer analysis, fluid mechanics and composite structures. All modules have a foundation subject and 2 application and practice subjects to help you gain experience with the specific software of your branch. In the next slides, the modules are briefly presented. More complete information about the subjects and modules is set out in the attendees guide on the master's website. The dynamic analysis module, available to both engineering branches, includes the study of dynamic phenomena that are present in structures or equipment. The initial objective of the fundamental subject is the analyzing of the dynamic problems that arise when calculating a structure. It also provides criteria to resolve them by focusing on specific structural types and providing the essential concepts while identifying the fundamental parameters which characterize the dynamic behavior of structural systems. The application and practice subjects introduce you to the concepts of dynamic analysis of structures, dynamic analysis such as modal analysis, harmonic analysis, spectrum analysis, random analysis, and transient analysis are studied during the course and are applied to real problems using the FIM software. The study of this module will help you to understand and learn how to create and analyze dynamic cases of finite element models such as seismic studies of components, buildings or dams, and enforced vibrational studies in different industries: automotive, aerospace, energy, marine, civil, etc. The purpose of the nonlinear analysis module is to study the nonlinear problems associated with structures. All the main nonlinearities present in reality, like strains and displacements, material and contact, are included. A complete understanding of this behavior is achieved with the study of the concept of nonlinear structures, the kind of problems that require a nonlinear analysis, the causes of nonlinear behavior, and the differences with linear analysis and the characteristics of nonlinear analysis using finite elements. All of the concepts and the study of these behaviors are applied to real problems in the application and practice subjects using the finite element commercial software. The study of this module helps you to understand and learn how to create and analyze nonlinear finite element models, such as in contact mechanisms, nonlinear buckling analysis in structures, construction processes, nonlinear materials, and geometric nonlinearities, etc. The aim of the heat transfer module is the study of heat transfer phenomena. The fundamental subject provides the theoretical knowledge about heat transfer necessary for a specific application in the resolution of general and finite element heat transfer problems, as well as in stationary or non-stationary systems. In the application and practice subjects, you come into contact with and manage from the perspective of conducting analysis using finite elements the basic concepts of heat transfer such as conduction, convection and radiation, while at the same time solving stationary or transient heat transfer problems and other peculiarities of thermal processes, which can be treated like nonlinearities. The study of this module helps you to understand and learn how to create and analyze heat loads in finite element models such as thermal studies of heat exchangers, thermal studies in electrical components, thermal behavior of pressure tanks, etc. Some heat transfer analysis examples which are solved in the practical subjects of this module are the thermal analysis of a fined tube, a heat sink design procedure, a radiation analysis of a system or the thermal stresses in a section. The fluid mechanics module studies problems associated with fluid mechanics, including their characteristics and modelization in order to analyze them using CFD simulations. The theoretical subject studies the fundamentals of fluid mechanics with a particular emphasis on deduction and analysis of mass conservation equations, movement quantity and energy. Furthermore, the characteristics of different flow types are described and the conditions in which the different simplified shapes of general equations can be applied are discussed. Lastly, the finite volume method is applied to some of the flow types studied. The application and practice subjects of this module are studied with ANSYS helping you to understand the main approaches used in CFD simulations. Mesh-based CFD techniques are studied with the ANSYS along with previous specific training in CFD geometry pre-processing procedures. The study of this module helps you to understand and learn how to create and analyze computerized fluid dynamic modules such as aerodynamics studies in automotive, structures or aerospace, internal flows in heat exchangers or valves, hydrodynamic studies in the marine industry or water management, ventilation studies, behavior of wind turbine, multi-fluid flows, etc. Here you can see some examples of CFD fluid mechanics analysis solved in the fluid mechanics module. The ventilation inside a parking area, checking the smoke behavior created by fire, the simulation of a bullet in supersonic regime, the simulation of the interaction between two aligned turbines, checking how the wake of the first turbine affects the second turbine, a vortex shedding simulation to check the frequency and amplitude of the loads created by this phenomenon, and the optimization of a water treatment structure using a deflecting wall to improve the suction of one of the pumps. The aim of the finite element analysis of composite structures module, only available in the mechanical branch, is to introduce you to the concepts and analysis of composite structures. The theoretical subject first studies the composite structures from an analytical point of view, from simple to more complex composite structures, while also presenting common failure criteria and general design concepts and their comparison against experimental data. from which the theories that are applied to the study of this particular field are derived. The second part of this subject introduces how this type of material is treated in a finite element code. The application and practice subjects helps you to manage the analysis of composite structures with the commercial software ANSYS. The study of this module helps you to understand and learn how to create and analyze composite finite element models such as aeroplane fuselages, high-level sporting materials, automotive parts, wind turbine blades, etc. Some interesting examples of composite structures which are solved during the study of this specialized module are the stress concentration study of a pipe joint, the analysis of a composite aircraft wing, or a composite beam. The theoretical and practical application of the Finite Element Method and CAE Simulation Master's Program concludes with the final project. This project combines all the knowledge that has been acquired throughout the study phase of the expert and specialist modules and aligns all their aptitudes and capabilities under a common goal in a single project. A tutor is assigned to each project, depending on the areas involved, to guide you during the project process. The project can be proposed by you based on your professional experience or chosen from the master's official list. At this point, I will give you useful information on the program calendar and important dates, candidate requirements, the registration process, and scholarships and fees. Enrollment is now open. It is recommended to register early to facilitate the necessary confirmations and the payment of fees, etc. The expert module starts on February and finishes with the final exams in October. The specialized modules and the master's final project start in May, finishing with the exam period in November. Attendees who were not successful or were unable to take the first exam call of the expert module can take advantage of the second call. This slide shows the fees for each module. But what I want to make clear to you is, you only pay for the modules you take. To undertake the master's program, you must have a bachelor's degree. To register, you need to complete the online application and submit the requisite documentation for verification at the same time. Once your documents have been validated by UNED, the remaining part of your registration will then be completed. Here are the contact details of the Master's Secretariat. Don't hesitate to get in touch with the Secretariat if you have any questions about the program. The Master's website is the place to go to start the registration process.
You will be pleased to hear this slide brings the session to an end. We hope you have obtained a good understanding of these international masters in theoretical and practical application or the finite element method and CA simulation. Once again, don't hesitate to get in touch with us if you wish to have any matters clarified or require more information. Use the Secretariat email address and we will be more than pleased to help you. Of course, any questions you might place in our tool will be answered ASAP. Our international masters could well be the right opportunity and the right time for you to invest in your professional career and your future, and UNED and Inge Cyber are here to help you achieve your goals and fulfill your dreams. We would like to thank you for your time and presence today. Till the next time, take care and goodbye.